2019 FRQ number 2. This time we don't have to really look at a lot of cues and, main ideas and strategies, because the cue is it's polar and the main ideas is polar coordinates. So we had a whole chapter on that and just everything that's in there. So things that we expect, find the area, average distance, two areas that are the same, and then some other kind of area involving a limit. All right, so it's just a lot of area stuff. So part A is just find the area. So here's our function. So one thing again that I've done, because we only have one function this time, but I'm still gonna have to use it a bunch of times. So I did a couple of things, which is one, I went into my mode and I set myself in polar mode. So you have func mode over here, that's functions. You have parametric mode here, and we're going to use polar mode. Now, a lot of this you actually didn't have to use polar coordinates to do, but I found it was helpful in the last section. So I went ahead and set polar coordinates at the beginning, and then when I go to my y equals, I have everything in terms of r and theta, and I already put the function in. So now I've got that function in as r1, so now I need to find the area. So to find the area, all I have to know is that for the area of, oh geez, did I just clear that function? That's, I hit the button with my finger when I move the calculator. That's pretty irritating. So it is 3 square root. Am I going to start the video over because of that? No, I'm not. I'm just going to type it in again. Sine of, and then I'm probably going to hit it again with my finger. Theta squared. All right, so that looks like my correct function. Okay, recovered. Now, what I have to know is that the area is the integral of 1/2 r squared theta d theta, and that's because the area of a sector is 1/2 r squared theta. So I go back to this because it relates to the area of a sector, but if you want to pull the 1/2 out right away, that's probably a smart thing to do. So that's our integral for that. And now I just have to do the integral. So I'm going to go to my calculation window. For the 1/2, I'll just put 0.5. It's just quicker. And then I'm going to go, I might not need the times, but I would just stick it in because if it did want it, then I don't have to go back and fix it later. I don't want second. I want math 9 for an integral. We're going from 0 to, and they told us what the interval here is. If they hadn't, I might have to solve the equation, but they told us it's 0 to square root pi. So I'm going to go 0, and then up here I'm going to do square root pi. It's no problem just sticking that in there. Now here's a trick with this though, because I'm in polar mode. When I go to do variables, y variables, I do not pick function. I have to skip down here to polar. I found that out the hard way. So we go down here to polar, and then I can pick my R1, because otherwise it would be Y1 and would have a conflict of variables. So then we have theta there, and I just hit the button, and it gives me 1.400, which I'm pretty sure is totally wrong because I forgot the squared. So let's try it again, and this time I'm going to put in the squared. So we're going to go insert a parenthesis, and then over here we're going to insert a close parenthesis and a square, and this time it's going to be right because it is 3.534. I like that much better. All right, so don't forget to square it in your calculator. It equals 3.534. Remember, there's no units because it's math, and nothing we talk about is real anyway. But let's just double check. Does it say units? No. Does it give units? No. The area is 3.534. And that's part A. Not too bad, right?